Section, we're going to discuss the string data type. This will introduce a few new concepts, the difference between primitive and reference variables. The string type is a sequence of character values. We've discussed those. Those are single letters, digits, or punctuation marks, but a string is a group of them together, much the way we would write a word, a phrase, or a sentence. Characters use apostrophes for delimiting, and strings use quotes. We interpret a string as readable text, something we would see on the screen for human consumption. The memory characteristics are a little more complicated than before. We have a reference variable, which is just a normal variable, plus an additional area of memory. The two work together. The range of values per character is any legitimate Unicode character. There's no limit to how many characters can be in a string. The set of operations is extensive. Consult the documentation for a full list. Some common operations are things like getting the length. If we have a string called text and we assign it the value hello world, we would say that the length of the string is 13, 10 letters and 3 punctuation marks. To get an individual character, we would say text.charat and then in parentheses give it an integer value, such as 7. So if you start with capital H and count over 8 characters, you'll see W. The reason the value 7 is used is because we start counting at 0, not at 1. It's called zero indexing. Capital H is at index 0, making lowercase w at index 7. Concatenation is the joining of two strings together into a new string that is simply a combination of the two. For example, I said, comma, blank plus text results in a new string I said, comma, space, hello, comma, world, because text has the phrase hello, comma, world. Substring operation is one whereby we start at a particular character and then grab either all the remaining characters or a different form, a limited number of characters, and pull out a new string that is generally smaller than the original string. For example, here we say substring starting at index 7, and we would get all the remaining characters from text. So we would get the word world. And finally, if you want to check the location of a particular character starting from the left, we say text.index of, and notice apostrophes. We delimit the W with an apostrophe because it's character, and it returns an index of 7. Strings are fun. They're very common. There are many shortcuts using them. Unfortunately, that leads to distressing problems for beginning programmers. String S1 is assigned hello, comma, blank. String S2 is assigned world. String S3 is the concatenation of S1 and S2. S3 would print out the value hello world. The plus symbol seems like it would be a handy way to add any two reference type variables together, but technically it's not adding them at all. It's taking the values they refer to, in this case hello and world, and joining them together, creating a whole new string. It doesn't work the way it looks. So just remember, we're not technically adding the values S1 and S2. We're going and getting the data they refer to, the strings, and joining those together and creating a whole new string. No other class uses this symbol. Primitives do in mathematics. In this case, they would be numeric variables, and the contents of those variables would be summed. Strings allow easy creation by simple assignment. String S1 assigned hello. Unfortunately, it can mislead you into thinking S1 is the value hello. S1 is a location or a reference to another area in memory where the string hello actually exists. S1 is equivalent to the statement string S1 assign new string, and inside that hello, with one minor exception. That's technically how a reference variable is created and initialized. String S1 assign new string hello. The syntactic sugar is on the left-hand side. String S1 assigned hello. That's a shortcut. It's convenient, but it can be misleading in what it's doing. This shortcut suggests that all objects should be created by assignment. It's not true. Only string does this. Now here's a picture of two different types of variables. The one on the left, I, is defined as an integer, and we assign the value 42. Notice the box next to the letter I, the variable. It has the value 42 in it. That's the way we would assume things work. When we refer to the variable I, we're really referring to the value 42 stored in it. The reference variable, on the other hand, works differently. We say string S, and S is a box that has a value in it, but that value is not the data of interest to us. That data stored in that reference variable S happens to be a memory address where the string hello is located somewhere else in memory. Notice the arrow. I point an arrow to the string off in memory somewhere else. That means S is a reference variable. We don't care about the actual value in S. What we care about is that it correctly refers into memory somewhere at a location where the string hello is. More complications arise when we compare strings. Assume at the top S1 new string hello, S2 same thing, S3 has the simple assignment initialization, as does string 4. When we test for object identity, what we're doing is taking those two reference variables and saying, do they refer to the same location? When we say S1 equal S2, what we're saying is, does reference variable S1 refer to the same location in memory as reference variable S2? If so, then we're referring to the same object. And in our case, string 1 and string 2 are not equal, because when we create string 1, we grab some memory, initialize it to the phrase hello, and assign that location to variable S1. When we create string 2, we do the same thing, but it's a different location in memory. Happens to be the same word, but it's a different location. It would be analogous to two friends, both named Bill, living in two different houses. They each have the same name, but they live in different locations. The second test is for object equivalence. This is what you would want to do almost always when you want to compare strings. You would say S1 dot equals S3 in this case. So we're asking, does the contents or the string referred to by S1 have the same characters in the same sequence with the same case as the characters for S3? And in both cases, it's hello. So yes, that would be true. That means the values referred to are the contents of the objects themselves, off in memory at some location. They have the same value. For efficiency reasons, the Java compiler does string pooling. Oddly enough, S3 and S4 refer to the same object. So when I compare, does S3 equal S4? The answer is true. Back to S1 equal S2, because I created new objects, they each get their own location. For efficiency reasons, when I refer to hello, when I create string 3 and string 4, the compiler just simply says, well, they're both hello. No need to create it twice. We'll just do it once. S3 would refer to a location where hello is. S4 would refer to the exact same location. And that way we don't have lots and lots of hellos scattered throughout memory. If we can, we share them. Not every other class does it this way, but strings do. My summary of this is, be careful when you're comparing strings to make sure you're actually comparing the right thing. Are you comparing the reference variables that contain the location of an object, or are you comparing the object's contents? S1 equal S2 is saying, are you the same object? Do you have the same location as each other? S1 dot equals S3 says, is the value that you have in the string, hello, the same?